Today we're going to talk about combination circuits. That means circuits that have both resistors in series and in parallel. And I'm just going to jump right in and show you some examples. So imagine that we have this, so we've got a series, but on this leg we have two resistors. This is 10 volts. They'll make this 3 ohms. We'll make this 2 ohms, and this will also be 2 ohms. So let's just find the resistance. Oops. The equivalent resistance of the circuit. Well, how do you do it? You have to do each branch or each part by itself. So first thing we have to do is figure out the equivalent resistance for these two 2 ohm resistors in series. So here's what we're basically doing. We're redoing our circuit so that instead of 2 2 ohm resistors, we're just going to have one resistor. Well, in series, what do? You just add the resistances. So now that's equivalent to a single 4 ohm resistor. And here we still have our 3 ohm resistor. Okay, well now this is just parallel. So how do we find equivalent resistance in parallel? Well, we have to do 1 over R equals 1 over 3 plus 1 over 4. Okay, so 1 over R equals, well, let's see. Here. Say 1 over 3 plus, I probably ought to use parentheses. This is something you guys have been struggling with. 1 over 3 plus 1 over 4 0.583 repeating. Okay, so that equals 0.583. So solving that for R is going to equal 1 divided by 0.583. Just going to do with this one. 1 divided by 0.583. So the equivalent resistance turns out to be about 1.7 ohms. Alright, we just took this part, figured out the equivalent resistance, which was 4. Then we took these, used the rule for parallel circuits to get the equivalent resistance of the whole thing. Let's do another one. What if this time it looked like this? I have a resistor here, and then a resistor here, and a resistor here. Maybe this is 6 ohms. This is 3 ohms. And maybe this is, I don't know, 2 ohms. Well, first thing I want to note is that it doesn't matter that this is on the top of the circuit. This is just, circuits usually drawn sort of rectangularly, so it's this 6 ohm resistor is in a series with these two circuits and these two resistors in parallel. So the first thing we need to do is figure out the equivalent resistance. We've got our 6 ohms here. We want to figure out the equivalent resistance to this. how many ohms is these two parallel circuits, these two parallel resistors. How many ohms are these two parallel resistors equivalent to? Well, same thing we just did a second ago. 1 over R equals 1 over 3 plus 1 over 2. I happen to know those fractions off the top of my head. That's 1/2, 0.5, and 0.3, so it's going to be 0.83. So R is going to be 1 over 0.83, which is about 1.2 ohms. So about 1.2 ohms. 1.2. And now, these are in a series, so we can just add them. So our total resistance is just going to be about 7.2 ohms. They just do each step independently of another. Alright, so now let's find the equivalent resistance of this circuit. Okay, don't let yourself get overwhelmed. We're going to take this one step at a time, and we're going to simplify it as we go. Okay, so we got a 4 ohm resistor in series with this parallel array, but we've got a series inside the parallel array. Okay, and that's in series with another parallel array that has another series inside it. So let's handle each of these parallel arrays first. Let's start with this one. Well, before I can do anything, I need to figure out the equivalent resistance of this 1 and 2 ohm resistor. Well, hopefully we all know that for that we can just add it together. 1 ohm plus 2 ohms is the same as 3 ohms. Okay, now we have a three-way parallel, so 1 over R equals 1 over 5 plus 1 over 3 plus 1 over 3. I'm going to use this calculator to do that. 1 over 5 plus 1 over 3 plus 1 over 3 gives me 0.866. So 1 over R equals 0.866. So R equals 1 over 0.866. Let's just do that here. 1 over the answer, about 1.5 ohms. 1.15 ohms, excuse me. About 1.15 ohms. So what we can do is we can take this whole parallel sequence out and replace it with its equivalent, which would be a 1.15 ohm resistor. Okay, this looks a lot easier already. Alright, let's handle the other one. 4 and 7, well, that's just a series, so we know what 4 plus 7 is. It is 11, so this is the same as a single 11 ohm resistor. 11 and 2, hey, those are in parallel, so 1 over R equals 1 over 11 plus 1 over 2. One over 11 plus 1 over 2, 0.59. So 1 over R equals 0.59. R equals 1 over 0.59. About call it 1.7 ohms. So we can replace that parallel with its equivalent, which would be a single 1.7 ohm resistor. And now we just have a series, so we can just add. So the equivalent resistance of the whole circuit is what, 4, 5, 6, 6.85 ohms. And that's not that hard. So I could just make this impossible looking gigantic array of circuits and resistors and ask you for the equivalent resistance of the entire thing, and it's really not that bad. Just break it down step by step as you go.